Welcome to the 2010-2011 winter edition of the Rensselaer Research Review. We're going to take the next few minutes and talk about some of the current research going on at Rensselaer Polytechnic Institute. Rensselaer graduates were there from the beginning as IBM conceptualized and created a computer named Watson that challenged the most accomplished Jeopardy contestants. David Ferrucci, class of '94, the IBM lead scientist on the project, earned his PhD at Rensselaer. Chris Welty, class of '85, who earned all three of his degrees at Rensselaer, was a member of the IBM Watson Algorithms team and a former director of Rensselaer's Computer Science Laboratory. And Welty's fellow IBM algorithm team member, Adam Lally, class of '98, worked on the Watson project. On February 14th, 15th, and 16th, Rensselaer researchers joined an enthusiastic audience of students and visitors to watch as Watson faced off against two all-time Jeopardy champions. The Jeopardy Ibm challenge was shown on the large high-definition screen in the MPAC concert hall. All three events included panel discussions featuring Rensselaer professors and administrators and IBM experts before the show aired, and each show was followed by a question and answer period with the panel. Visualization involves seeing new things in new ways, and thanks to new tools, new knowledge, and new interest, visualization is emerging as a promising intellectual frontier. Professor Barbara Cutler has created virtual rooms in which you can see the effects of incoming sunlight at any time of the day or the year at any location. She also has projected 6-foot-high 3D images of the brain using a unique multi-camera format. By moving panels around, selected slices of the brain can be projected inch by inch and along any plane and made visible at such a scale that they can be shared and commented upon by an audience. In another approach, Professor Richard Radke is exploring the use of lasers to create 3D images that provide direct, useful visual information on things like streets, houses, and power lines that can be surprisingly variable in the real world. One project includes scanning all the buildings on the Rensselaer campus, creating datasets that allow for understanding the changes brought on by weather or growing foliage without losing basic information on these places. Building on an enzyme found in nature, researchers at Rensselaer have created a nanoscale coating for surgical equipment, hospital walls, and other surfaces which safely eradicates MRSA, the bacteria responsible for antibiotic-resistant infections. The new coating marries carbon nanotubes with lysostaphin, a naturally occurring enzyme used by non-pathogenic strains of staph bacteria to defend against MRSA. The resulting nanotube enzyme conjugate can be mixed with any number of surface finishes. In tests, it was mixed with ordinary latex house paint. Unlike other antimicrobial coatings, it is toxic only to MRSA, does not rely on antibiotics, and does not leach chemicals into the environment or become clogged over time. It can be washed repeatedly without losing effectiveness and has a dry storage shelf life of up to 6 months. A few unassuming drops of liquid locked in a very precise game of follow the leader could one day be found in mobile phone cameras, medical imaging equipment, implantable drug delivery devices, and even implantable eye lenses. Engineering researchers at Rensselaer have developed liquid pistons in which oscillating droplets of ferrofluid precisely displace the surrounding liquid. The pulsating motion of the ferrofluid droplets, which are saturated with metal nanoparticles, can be used to pump small volumes of liquid. The study also demonstrated how droplets can function as liquid lenses that constantly move, bringing objects into and out of focus. Researchers at Rensselaer developed an entirely new type of nanomaterial that could enable the next generation of high-power rechargeable lithium-ion batteries for electric automobiles, laptop computers, mobile phones, and other devices. The new material, dubbed a nanoscoop because its shape resembles a cone with a scoop of ice cream on top, can withstand extremely high rates of charge and discharge that would cause conventional electrodes used in today's lithium-ion batteries to rapidly deteriorate and fail. Aerospace engineering expert Michael Amate has received a $250,000 grant from the New York State Energy Research and Development Authority to continue his work on smarter blades for wind turbines. For the past 3 years, Amate has led several studies into new technologies that could optimize wind turbines for upstate New York's gusty, turbulent winds. In this region, the wind is inconsistent and wind shear values can be rather high. This leads to wind turbines operating inefficiently and also increases the risk for structural damage to the turbine blades. Thank you for listening to the Rensselaer Research Review. For in-depth versions of these stories, please visit rpi.edu/research/magazine. For more RPI podcasts, please visit rpi.edu/news/podcasts.